Good day friends. Today I shall talk on 10 basic statistical concepts for data science. In data science, we use concepts and tools from statistics, mathematics and computer science. Here we present 10 basic statistical concepts that we need in data science. To start with, data visualization. Just seeing at the numbers, just seeing at the data, one doesn't get anything, one doesn't understand anything. So we need to summarize the data. So these are the data visualization or sort of summarization of data. First, starting with histogram, we have the values of the variable on the x-axis, the means and the frequency of the variables, or the relative frequency of the variables on the y-axis. So this talks about a lot about the variable, whether it's bell-shaped, whether it's unimodal, whether it's symmetric, and accordingly we choose the distribution of the population. So this is histogram. Then comes box plot. That's also a summarization of variable. We have Q1, the 25th percentile, and here we have Q3, the 75th percentile. In the middle we have the median. These are based on the medians and the percentiles, so these are quite robust. And then we have interquartile range, which is Q3 minus Q1, and Q1 minus 1.5 star interquartile range is the minimum, and Q3 plus 1.5 star interquartile range is the maximum, and outside that we have outliers. So this is a picturization of a variable. We get to know a lot about it, how much is the variance, how big is the interquartile range, that's a measure of variance, and where is the mid value, that is the median, etc. And then if the distribution is symmetric, Q1 and Q3 are spaced equally spaced apart from median. So that's box plot. Then comes scatter plot. When you have two variables, x and y, say x is the time variable here and y is the local index. So and each point denotes an occurrence of a pair, year and local index. So that's the scatter plot. Then we try to fit a curve to the line to do some predictions, etc. Or we fit a straight line, which is statistical regression. So any bivariate analysis starts with scatter plot. Then we have descriptive statistics. We have these are also summarization. We need to know the central value of the data. That's measure of central tendency, which are mean, median, mode. Then measure of variability, how the data is scattered around the middle value, central value, the variance, range, standard deviation. These metrics help you understand your data set at a glance. So again, just looking at the data, one gets nothing. We need to do some summarization. And measure of central tendency, measure of dispersion, measure of skewness, measure of kurtosis. These are the measures by which we extract from data and we get an understanding of the data. So mean is the average value summation xi by n. So that's the popular measure of central tendency. Then we have variance, sigma square, 1 by n summation xi minus mu whole square, which is the population variance. And if we replace mu by x bar, we get the sample variance. Then we need to know about the probability distribution. I will talk about two distributions. One is binomial and another is normal. Suppose we toss a coin 10 times. What is the probability of getting 5 heads? That is, after some calculation, if the probability of head equal to probability of tail equal to 0.5, that is, the coin is unbiased, then the probability is 10c5, 0.5 to the power 5, 0.5 to the power 10 minus 5, which is 0.246. So when you toss a coin 10 times, getting 5 heads, the probability of getting 5 heads is 0.25. That's binomial distribution. Here is the general mathematical formula: nck p to the power k 1 minus p to the power n minus k, value of k starting from 0, 1, 2 up to n. Then we have continuous distribution, which is normal distribution. In discrete distribution we have PMF, probability mass function, but in continuous distribution we have probability density function. The area under the curve of which comes out to be the total probability, which is 1. So for normal density with mean mu and variance sigma square, is given by 1 to root 2 pi sigma e to the power minus half x minus mu by sigma whole square. So that's the normal distribution we use in data science. Then joint distribution of two variables x and y. We need to calculate covariance of x and y. Summation I 1 by n, summation I equal to 1 to n xi minus mu of x, y times yi minus mu of y. When it is positive, when one increases with the other, it is positive, and when one decreases with the increase of other, it is negative. So that's covariance, and from that we get the correlation function, which is covariance by sigma x, sigma y. That takes value between minus 1 to plus 1. When the value is plus 1, which is rarely true, we say it's positively correlated. And when it is minus 1, we say it is the variables are negatively correlated, and in between, when the correlation is 0, we say there is no linear relationship between the variables. There is no correlation. Then comes central limit theorem. It states that the distribution of sample means approaches a normal distribution as the sample size become large, regardless the population distribution. What is the underlying population distribution doesn't matter, but if x1, x2, xn is a sample, xn bar converges to normal mu sigma square as n tends to infinity. Larger is the sample, better is the approximation to normality. Then we have hypothesis testing. We have null hypothesis H0, alternative hypothesis H1, and we do a test, say z test, when sigma is known, x bar minus mu 0 by sigma by root n. When it is large, based on this we reject or accept the null hypothesis. Then comes the method of p-value. The p-value tells how likely it is that one's result happened by chance. So p-value is the probability of getting as extreme as the value as the observed, and if the probability is very low, then we say that there is not much statistical support behind null hypothesis. So when p-value is less than 0.05, we reject H0. Sorry, there is a typo. This should be less than 0.05. We reject H0. Otherwise, we fail to reject H0 or we accept H0. Then z-scores and t-scores. When sigma is known, we use z-score. When sigma is unknown, we use t-score. And the formulas are x minus mu by sigma, which is normally distributed. And then when sigma is unknown, we use t equal to x minus mu by sample standard deviation s by root n. And based on this, we do the hypothesis testing. Then comes confidence interval. Given data, what is the confidence interval of the mean? So what is the confidence interval of the average height of people in Kolkata? So that is given by sample mean x bar plus minus z0 0.95 into sigma by root n when sigma is known. So this value is from standard normal variable and is available on table. So this given the confidence limit, we say that the mean lies in this confidence level with 95% confidence. Then comes ANOVA. So we have columns of data, total sum of square equal to sum of square within columns plus sum of square between columns. That could be proved mathematically, and accordingly, using the degrees of freedom, we create the mean square within, mean square between, and we do a f test, mean square between by mean square within, with the corresponding degrees of freedom, and we test whether the means of the different groups or different columns are same or not. That's the null hypothesis. So this entire talk is taken from a Medium blog. Here is the blog. Ten statistical concepts every aspiring data scientist should know. The Davinger's Guide. This is based on this Medium blog. I'll stop here. Thank you.